Everybody, now we're gonna show you how to build the MOSFET and try to get the VDS and VGS with sweep DC. First of all, we're gonna start to open the Synopsys tool since it's been stored in Noor server. We need to go first to the internet. We already saved it as a website called Nice Engine Frame. For this one, Synopsys. Then click on the Synopsys and it will download. We open it from downloader, double click on it. Now we have a window which in the Linux system, and to open any program stored in that system, we have custom design, we have TCAD, we have more options we have Saber. First of all, we go application, system tools, terminal. In this window, we need to write model load Synopsys 2015, then enter. Then it will lead you to my username Asharha, and I'm here. And to open custom design, we need to write CDE, or we can write it by ourselves, CDE, then enter. Then it will take you to Galaxy Custom Designer, or Galaxy, we don't know the exact. Now we need to build the circuit MOSFET and with two sources, VGS and VDS. First of all, we will file, new library. We'll name the library as test underscore EE202, and the directory will be, let's make it the same place. Let's try. Then we go file, new, make cell view. We look up our library, which is this one, and we need to create cell view. Let's name it NMOS3, and we need to have it as schematic, and the editor we need to use schematic editor. If we use here Verilog, we can Verilog layout. If each one has his editor, now we use schematic editor. Then we'll say okay. Now we have blank. Let's bring the component. We can have the component from here or press I. So in this window, we go to library. We have many libraries. Let's choose this library for MOSFET, the channel length 90 nano. We have this component. Let's take N MOSFET, and we have also B MOSFET. This is 3 terminal. Then let's put it. Change the library. Go to analog. Where is the analog? Go. We need V source. Let's write it here, V source, or you can scroll down until you find it. Let's put it here. This is for VDS or VDS, and this for VGS. Now we need ground. Ground, you find it here, or scroll down. Ground. If you could find it, it's there, but you can type it in, and it's easier to find it. Where is it? Bloody hell. Gee, yes, this one, ground. Then we put the ground here, say cancel. Now we have our component. Let's take it, organize it a little bit, put it here. And here this program is quite complicated, but it has more feature and people use it in the industry more than academia. Now we need the wire. You can take it from here or press W, shortcut for wire. Connect it to the gate, the drain to the source, and this to ground, the source to ground. Here and here. Okay, now we have, if the schematic is ready, and this escape. Now let's change the value of this one. You can press on it, then press Q, click on it, then press Q, and go here, and shall we name it VDS? And okay, let's say apply, and here we shall name it VGS, and this value, it will be swept. So the value, instead of writing 0, a fixed value in our VGS, then we take it and sweep it. Now we need to simulate the circuit, and we need to simulate to measure ID here. Now we need to apply VGS here and sweep it from 0 to 2, and we have two values of VDS, let's say 0.1 in linear region and 2 in saturation, and we see the difference between them in log scale. Let's go on tool, this system analyzer, SAE. First of all, we go to setup to choose the tab of analysis. This analyzes, since we have we need to sweep it, we need DC, then it's easier to use this command, write dot DC, and first sweep it for VGS, choose this one, starting from 0 to 2, and the step is 0.05. This is give you the resolution. The second one, VDS, starting from, let's say, linear region 0.1 and 2 as saturation, and the step 2, we need like 2 steps. We don't want to have the resolution between them, so that means we need 2 lines. This case we subtract the 0.1 from 2. That means 2 minus 0.1 equal 1.9, which is the step. That's now we have like 2. Let's say okay, and we need now to have specify the node where we going to measure. Press here, then in this arrow we need to measure the ID here. If you click here, that means we need the current. If you click on the wire, we mean the voltage. Okay, we click on here. Now we have this current in the drain. You can name it as well. Let's say ID, or leave it the same, and put the variable, copy from the design. It gives you the variable in the design. Let's give it 0 value. That means this avoiding floating. Now inshallah it's gonna work. Let's go here, list and run. Okay, now it's failed. Let's go back and check what's going on here. Excuse me, we can't find the problem in here. This saying that there is a problem in here. Let's delete this. How to delete it, I don't know. From here, from here, let's have wire. Let's write it again. Okay, let us simulate it. Oh, we forgot something. We don't have the model. We need to attach the model. Now the MOSFET is 90 nanometer, but we don't have that the model of it. So we can go here and model file. We go here. اسمع تعال انحشرت والله وانا قاعد اسجل. تتذكر فين تحت بسرعة وانا قاعد اسجل فين محلها الفايل. ايوه ارجع. This is the last one. Okay, we got help from Abdullah Turki. Thank you for your help. Then we go here and found it here and have this lab. And this one should be typical 12. أوثان. Now hopefully so if it work we're gonna go to Braille Asr inshallah. Wow, it's working now. We can look scale. I'm gonna send it to all the class. Okay, now we have two. This is for 0.1 linear region, and this the difference between them called dipole. We take it with this in class 203. And if you want more information, you can contact Professor Muhammad Hussein, and he will let you give you any information about this one. Thank you guys for watching this video, and I'll see you for our next lecture.